Factors and multiples. Factors. A shopkeeper has to display 12 bottles of jam in his shop. He can arrange them in different ways. Number 1. He can arrange them in one row. One row of 12 bottles or 1 multiplied by 12 is equal to 12. Number 2. He can arrange them in two rows. Two rows of 6 bottles, that is, 6 multiplied by 2 is equal to 12. Number 3. He can arrange them in 3 rows. 3 rows of 4 bottles, that is, 3 multiplied by 4 is equal to 12. Here, 1, 2, 3, 4, 6, 12 are all factors of 12. When numbers are multiplied, they give the product. Each number which is multiplied is the factor of the product. Determining factors of a product. When a number divides another number exactly, then the divisor. Determining factors of a product. When a number divides another number exactly, then the divisor is called factor of the dividend. Let us take a number, say 30. Divide the number by 1, 2, 3 and so on. 30 divided by 1 is equal to 30 or 1 multiplied by 30 is equal to 30. 30 divided by 2 or 2 multiplied by 15 is equal to 30. 30 divided by 3 or 3 multiplied by 10 is equal to 30. 30 divided by 4 not possible. Hence, 4 is not a factor of 30. 30 divided by 5 is equal to 6 or 5 multiplied by 6 is equal to 30. 30 divided by 6 is equal to stop because we have already found 6 as a factor of 30. So, 1, 2, 3, 5, 6, 10 and 30 are all factors of 30. We can build a product using more than 2 numbers. All the numbers used to build a product are the factors of that product. Examples: 3 multiplied by 5 multiplied by 7 is equal to 105. Here, 3, 5, 7 are factors of 105. 2 multiplied by 5 multiplied by 11 is equal to 110. Here, 2, 5, 11 are factors of 110. When we divide a number by another and there is no remainder, then the divisor and quotient are factors of the first number, that is, dividend. Example 1. Find all the factors of 40. Solution: we have 1 multiplied by 40 is equal to 40. 2 multiplied by 20 is equal to 40. 4 multiplied by 10 is equal to 40. And 5 multiplied by 8 is equal to 40. Thus, all the factors of 40 are 1, 2, 4, 5, 8, 10, 20 and 40. Example 2. Is 9 a factor of 207? Solution: let us divide 207 by 9. Thus, 9 divides 207 exactly. Hence, 9 is a factor of 207. Properties of factors. Number 1. 1 is a factor of every number. Clearly, 1 divides every number exactly. Therefore, 1 is a factor of every number. Number 2. Every non-zero number is a factor of itself. Clearly, every non-zero number divides itself exactly. For example, 7 divided by 7 is equal to 1. 29 divided by 29 is equal to 1. Thus, every non-zero number is a factor of itself. Number 3. Every non-zero number is a factor of 0. 0 divided by 5 is equal to 0. 0 divided by 15 is equal to 0. Thus, every non-zero number divides 0 exactly. Therefore, every non-zero number is a factor of 0. Number 4. Every number other than 1 has at least two factors, namely 1 and the number itself. Examples: 1 multiplied by 15 is equal to 15. 1 multiplied by 256 is equal to 256. Number 5. The factor of a non-zero number is either less than or equal to the number. It is clear that the smallest factor of a number is 1. The largest factor of a non-zero number is the number itself. So, the factor of a non-zero number is either less than or equal to the number. Test of divisibility. We know that a number is said to be divisible by another number if on dividing it leaves no remainder. We can check by division whether a number is divisible by another number or not. This process may sometimes be lengthy. To avoid the lengthy process of division, we follow some rules of divisibility. Let us study these rules. Test of divisibility by 2. All even numbers are divisible by 2. So, 2, 4, 6, 8, 10, 12, etc. are divisible by 2. An even number has an even digit in its ones place. So, we find that a number is divisible by 2 if it has an even digit or 0 in its ones place. Examples: 92, 78, 186, 310, 944, etc. are divisible by 2. Test of divisibility by 3. A number is divisible by 3 if the sum of the digits is divisible by 3. Let us check the divisibility of following numbers by 3. Number, sum of the digits, conclusion. Number 1. 21. 2 plus 1 is equal to 3. Sum is divisible by 3. So 21 is divisible by 3. Number 2. 45. 4 plus 5 is equal to 9. Sum is divisible by 3. So 45 is divisible by 3. Number 3. 201. 2 plus 0 plus 1 is equal to 3. So, sum is divisible by 3. So 201 is divisible by 3. Number 4. 285. 2 plus 8 plus 5 is equal to 15. Sum is divisible by 3. So 285 is divisible by 3. Number 5. 10,575. 1 plus 0 plus 5 plus 7 plus 5 is equal to 18. Sum is divisible by 3. So 10,575 is divisible by 3. Test of divisibility by 5. A number is divisible by 5 if it has either 0 or 5 in its ones place. For example, 35, 70, 345, 71,560 are all divisible by 5. But 92, 293, 41,732 are not divisible by 5 because they have digits in their ones place other than 0 or 5. Test of divisibility by 10. A number is divisible by 10 if the digit in its ones place is 0. For example, 20, 40, 760, 950, 1130 are all divisible by 10 because they all have 0 in their ones place. Building factor trees. Factor trees is built by taking the given number as its roots. The circled number can be further broken up. We stop when we need to use 1 as a factor. 7 multiplied by 3 multiplied by 2. 7 multiplied by 6 is equal to 42. Example 3. Make factor trees for the following. A. 63. Solution. 7 multiplied by 3 multiplied by 2. 7 multiplied by 9 is equal to 63. B. 60. 2 multiplied by 5 multiplied by 3 multiplied by 2. 2 multiplied by 5 is equal to 10 multiplied by 3 multiplied by 2, 6. Now 10 multiplied by 6 is equal to 60. Common factors. Find out the factors of 18 and 15. Factors of 18. 18 divided by 1 is equal to 18. 18 divided by 2 is equal to 9. 18 divided by 3 is equal to 6. 18 divided by 9 is equal to 2. 18 divided by 18 is equal to 1. Factors of 18 are 1, 2, 3, 6, 9, 18. Factors of 15. 15 divided by 1 is equal to 15. 15 divided by 3 is equal to 5. 15 divided by 5 is equal to 3. 15 divided by 15 is equal to 1. Factors of 15 are 1, 3, 5 and 15. 1 and 3 are common factors of 18 and 15. So, common factors of 18 and 15 are 1 and 3. Example 4. Find out the common factors of 20 and 24. Solution. Factors of 20. 1, 2, 4, 5, 10 and 20. Factors of 24. 1, 2, 3, 4, 6, 8, 12 and 24. Common factors 1, 2, 4. Multiples. Starting from the minister's house, there is a police post at a distance of every 5 kilometers. Minister's house, 5 kilometers, 10 kilometers, 15 kilometers, 20 kilometers. Looking at the pattern of numbers, you can easily find out that the next post will be at a distance of 25 kilometers from the minister's house. Here, 5, 10, 15, 20, 25, 30 are all multiples of 5. Multiples of number can be determined by multiplying that number by 1, 2, 3, 4 and so on. 7 multiplied by 1 is equal to 7. 7 multiplied by 2 is equal to 14. 7 multiplied by 3 is equal to 21. 7 multiplied by 4 is equal to 28. 7 multiplied by 5 is equal to 35. 7, 14, 21, 28, 35, 42 are all multiples of 7. Example 5. Find out the first 5 multiples of 3. Solution. 3 multiplied by 1 is equal to 3. 3 multiplied by 2 is equal to 6. 3 multiplied by 3 is equal to 9. 3 multiplied by 4 is equal to 12. 3 multiplied by 5 is equal to 15. Therefore, the first 5 multiples of 3 are 3, 6, 9, 12 and 15. Example 6. Is 39 a multiple of 6? Solution. The number 6 does not divide 39 exactly. Hence, 39 is not a multiple of 6. Example 7. Is 154 a multiple of 11? Solution. There is no remainder. Therefore, 154 is a multiple of 11. Example 8. Is 419 a multiple of 13? Solution. 13 does not divide 419 exactly. Therefore, 419 is not a multiple of 3. Properties of multiples. Every number is multiple of 1. We know that 1 is a factor of every number. So every number is a multiple of 1. Number 2. Every non-zero number is a multiple of itself. 7 multiplied by 1 is equal to 7. 13 multiplied by 1 is equal to 13. 135 multiplied by 1 is equal to 135, etc. Thus, 7 is a multiple of 7. 13 is a multiple of 13. 135 is a multiple of 135. Number 3. 0 is a multiple of every non-zero number. We have read that every non-zero number is a factor of 0. Thus, 0 is a multiple of every non-zero number. Number 4. Every non-zero multiple of a non-zero number is either greater than or equal to the number. For example, the smallest non-zero multiple of 7 is 7. The smallest non-zero multiple of 15 is 15, and so on.